Hello, and welcome to yet another retro channel. Today we were going to be taking a look at the Sinclair ZX81, the British brother to the Timex Sinclair 1000 that we've been working on in the past few videos. Since that machine's done, it was time to get back to this one. I went ahead, I did make one modification to it in that I replaced the 7805 voltage regulator. If you remember from the first video on these, the previous owner or one of the previous owners was going to fit it with a Traco switching regulator, I think a TR2450. And I ended up using that in the Sinclair 1000. So for this one, I just went back to a standard 7805 voltage regulator with its associated heatsink, and that is working. The next step that I was going to need to make was to do a composite mod so that we could view this on a modern display device, modern monitor. The problem was that this is an early revision ZX81. It's an issue 1 board. It's not quite the earliest, but it is pretty early in that it has the second revision of the ULA. The ULA has had, I believe, 3 revisions. The 2C, I think it was 158, the 2C 184, which is this one, and the 2C 210, which is the ULA that's in my Timex Sinclair 1000. One of the main differences between these 3 revisions is how they handle the video signal. The 158 and the 184, the one here, produce a video signal without a portion called the back porch. The back porch is a small section of the signal, 4 microseconds, 4 nanoseconds, I forget which, 4.5, that tells the display device what the black level is, what voltage level represents black. And this ULA and the previous one do not produce that portion of the video signal. So doing a simple composite mod would probably not have worked in this case. It might have worked depending on how tolerant or how adaptable the display device is. But if I want to actually produce a signal that's more reliable on more display devices, I have a couple of options. One, I can try to find another 2C 210E ULA. The problem with that is that they are unobtainium. You can't find them. The second solution is to buy a modern replacement ULA, and those do exist. However, they're a bit on the pricey side as well. Probably more than the ZX81 itself is worth, so it's questionable whether you want to do that. The third solution is to add a small circuit that actually produces and adds the back porch to the video signal, and additionally creates the composite output. That's the direction I just decided to go. So I have placed an order for that circuit. It's a little more complex than I can build, or I might be able to build it if I had a pre-made PCB in the parts, but for me to actually come up with one or even build one from scratch on a perf board would be a little too difficult. So I have ordered one, and it's coming from Europe, and it may take a while. So we might not get back to this machine for a little while because anything else that I need to do with it, and obviously I need to upgrade the RAM, and I need to figure out what's going on with the ROM down here. But all that can come, will have to come after I get some video output out of it. We can't do much unless we can see what's going on. So in lieu of that, I actually have something else today. What I have is yet another British computer. What you see in front of you here is an Amstrad CPC 464. This is a 64K color personal computer, CPC, made by Alan Sugar's company, Amstrad. Alan wanted to get into the PC market. He wanted to compete directly with Sinclair, who at the time, I believe, had out the ZX Spectrum 48K and the Spectrum Plus. and he wanted to, frankly, give Commodore, I believe the phrase was, a good kicking. So he brought out the CPC 464. Now, this machine, it didn't do as well as Amstrad expected, or Amstrad wanted. There were reports that Alan wanted to sell 20 million of these. I believe the final sales figures were around 2 million. So he didn't beat Commodore, but he did take a chunk out of Sinclair's business, enough that eventually, when the time came, Sir Clive Sinclair sold Sinclair's computer business to Amstrad. So the later Sinclairs actually look more like Amstrad's. But I went ahead and I bought one of these, had it shipped over from Great Britain, and I have not hooked it up yet because I was waiting for an option to give it power and video. So we're going to take a look today and first of all see if the machine even works. So to do that, this has okay, these machines were originally sold with a monitor. You could get a green screen monochrome or a color monitor for about 110 pounds more. And something a bit curious about the way these work is that the monitor contained the power supply. So you'd hook up the monitor, plug it into the wall, and then a lead would come out of the monitor and plug into the CPC itself. And then you had a video port, which is a 6-pin DIN cable with an RGB output. And that would go back into the monitor. And there's an audio jack. So since we don't have the monitor, what we need to do is provide it with a 5-volt power supply, which I'm going to do from my bench power supply. And what we're going to do is we're going to hook it up through a SCART connector. And for those of you unfamiliar with SCART, it's actually used, either is or was used quite a lot in Europe. And it has a rather strange connector, but it has RGB. So I can feed RGB directly through the SCART. I have a SCART to HDMI converter box, and then it's being fed into both my little LCD screen and my capture device. So we're going to see if this works. Now, you hook up the 6-pin DIN connector. SCART apparently requires 5 volts to allow it to tell the display device to use RGB. So we're going to actually feed the 5 volts power supply through the SCART connector into the CPC. Here's my 5 volts from the bench power supply. And then we also need to hook up the audio. So make sure our power is off on the side here. To give you an overview of the computer, we have a full-size keyboard, which doesn't feel too bad to type on. It's a little soft and squidgy, but it works. Has colorful keys. These are in actually pretty good shape. I've seen quite a lot of these machines where the tops or sides of these colored keys take significant yellowing, like a regular beige computer like the Commodore 64 would go yellow or brown. These keys get that effect too, and they can be retrobrited, but it's an effort. I'm glad that the one that I bought here is in pretty good shape. It's a little dusty in places. We have a power LED. We have the main logo. You have a numeric keypad and a cross-function direction keys. And then one other thing about this device, this computer, is that it came with a built-in cassette drive. Now, I'm guessing we're going to have to do some maintenance, at least on the cassette drive. The belts are probably worn out or destroyed, and it probably needs lubrication and cleaning. We're going to see if we can get an output out of it. So I'm going to turn on my bench power supply. Set my amperage to 1, my voltage to 5 volts, and that should work. So turn on the output, and then turn on the computer. Okay, there we go. Just had to adjust my HDMI capture for PAL, and now you see there is the running CPC 464. I don't know how to brake. There we go. Escape twice apparently does it. Maybe we will give the cassette a try and see what happens. It did rewind all right. Let's see if it gets anything. This tape came with it. It's the only software I have for this machine. It's a game called Ghouls and Ghosts. Well, it's recognized the game. Let's see if we actually get any. Memory full. So we may have a memory issue with this machine. Let me find out if there's a way I can check memory. There is a set of diagnostics for this machine that were written by Noel of Noel's Retro Lab, and I will download that and burn it onto an EEPROM so that I can install it in this machine and run diagnostics. There may be a memory issue going on here. It's not uncommon for machines of this age to have memory chips go bad. So let me do some work on that and I'll get back to you here. Okay, so I have downloaded the Diagnostics ROM and programmed it onto this 27C128 16K EEPROM. Now we need to open up the CPC so that we can install it in the ROM card or the ROM slot. We have to be careful because this is probably one with the ribbon cables. There we go. So here are the keyboard ribbons. I don't know if you can see those here. Those need to be slipped out of their connectors. Some of the earlier models used wires and this header here, but that's not soldered on this one. Now we have a connector here which connects the cassette and the power and volume switches. So we're going to need to make a little adapter here to get the power switch on. For now, we will set this aside and take a look at our board. I will switch to overhead view and give you a little better look at the board. So we have, this is the RAM, this is logic. I believe that is the sound chip. That is the system ROM. So that I'm going to have to desolder and socket before I can use the diagnostic EEPROM. That I believe is an I/O chip. That is the Z80 microprocessor, and this is the more recent model gate array. So we're in luck there. So I need to take this board out. This board is pretty dusty, so it'll need a clean at some point, but not right now. And it is possible to use Noel's diagnostic ROM through something like a device called a dandinator, which is an external device that you plug into the expansion port that you can load, games through or whatever. However, I don't have one of those. I'm going to be getting one. I'll need to order the PCBs and the parts and build one. For now, however, we can use the diagnostics by replacing the system ROM. So what I need to do is desolder this guy here. While I'm waiting for my soldering tools to heat up, I should mention that my friend in the YouTube Retro Repairers group, Captain Commodore, or Lee, is the world's biggest Amstrad fan. He just loves machines, can't get enough of them. So if you ever watch his channel, be sure to leave him a comment about the high quality of Amstrad products and how great they are and how you might have grown up with them if you happen to have lived in the UK. He would appreciate that. One other thing I think I never mentioned about my desoldering technique, apart from the diagonal movement, particularly for a chip you're going to replace or reinsert, I tend to hold the board up when I use my desoldering gun, and the reason for that is if you leave it like this, gravity is working against you, holding the solder to the front side of the board. If you hold it up like this, you get a better chance of sucking all the solder through. There we go. So, came off pretty clean. I'm going to tidy up a couple of pins. And one pin that got a little bent. That should be pretty much ready for reinstallation. And now, socket. Our notch is on this end, so that isn't going anywhere. It's very tightly in those vias, so I don't need to dig out the blue tack. I'm also not going to need to do the diagonal corners trick. Okay, everything looks good. So we can install our Diagnostics EEPROM. Okay, now we need to make a bridge for the switch if we don't want to put the whole thing back together, which we don't. Okay, so I went ahead and off camera, I built a little switch bypass device, which is just going to connect pins 1 and 3 on this connector that goes to the tape drive, the power switch, and the volume control. And when I put that on there, that bridges those two. And then when we start up, like I said, we do have the diagnostic ROM in, so we should see it test RAM. If any of the RAM ICs are bad, it will report which ones, which bits, and then we can figure out which RAM ICs are bad. And then it'll let you test other things. And Noel did modify the ROM so that it does not require the keyboard anymore. It can be controlled through a joystick. So I have that connected. So let's go ahead and power on. Okay, there it's testing the RAM, and the RAM seems to have passed. We can run that test again if we like. Lower RAM. Pop the diagnostics back out again. And replace them with the system ROM. Make sure we orient the notch to the left. Looks like all the pins went in there. Let's see if she boots. Yep. Okay, so we're good there. I guess our next step will be to take a look at that cassette drive and give it a service. Also to clean this board up. I'll probably want to give it a good bath like I did with the Commodore 64s. So I will probably pull the gate array, the Z80, and the ROM, since they're in sockets, and give the thing a wash, and then let it dry thoroughly before we get back to working on it again. But in the meantime, I hope you enjoyed that quick introduction to yet another British micro that has made its way to the shores of America. And we will also be getting back to, as I said, the ZX81 once I get the little circuit board for the composite mod that also adds the back porch to the video signal coming from the 2C814 ULA chip. And that will be it for today. So if you enjoyed the video, please give it a thumbs up. I'd appreciate that. It helps the channel out. Also leave me comments. Again, it helps the channel, and it keeps me going, like I keep saying, with how you guys are so generous by engaging with me in these things. If you haven't already, please subscribe to the channel. Click the notification bell so that you get notified when I put new videos out. Share the video out to wherever you feel people would see it and enjoy the video. Be sure to check out my friends in the YouTube Retro Repairers group. Those would be 8-Bit Retro Refix, Joseph Retro Bits, Captain Commodore, and Retro 4U. There will be links to their channels in the description below. And keep an eye out. I do have something special coming up soon. I don't know exactly when, probably a couple weeks from now, but I'm going to have actually a guest video on my channel, and it might be something that particularly those of you interested in the C64 and modern software for the C64 will be interested in. More information on that coming when I have it. And that being said, everybody, stay safe and be well. Have a great week, and we'll see you next time. Bye.